Thanks, Steve. Good morning, everybody. Welcome. My name is Nate Larsen. I'm a project manager in Pacific Power's Customer Solutions Group. With me this morning is Kate Hawley, Associate Director of the Distributed Energy team at TRC. We're here this morning to discuss the framework and key learnings from Pacific Power's Oregon Community Resiliency Pilot. I'm going to start you guys off with a little background on what that pilot program was. But to begin, Pacific Power's highest priority is to provide safe, reliable power to the communities that we serve. But obviously, sometimes grid disruptions do occur. The Community Resiliency Pilot was designed to evaluate what steps can be taken to ensure the continuing operation of facilities critical to community emergency management and disaster response through the use of energy storage and associated technologies. Pacific Power first proposed a community resiliency pilot in 2018, partly in response to an emerging regional awareness of the threat of a catastrophic Cascadia subduction zone earthquake. Since then, the importance of ensuring the availability of critical services in impacted communities has only been magnified by the historic flooding and winter storms and wildfire events that Oregon has experienced in recent years. Sorry, we're still on slide 1, Steve. So the pilot kicked off in earnest last summer when Pacific Power brought TRC on board to help design the processes and provide some technical expertise in developing the pilot. And a side note, although we proposed the pilot to be agnostic to energy storage technologies, the pilot team reached the conclusion early on that lithium-ion batteries most closely aligned with the uses that we identified in the pilot. For today's discussion, we're going to begin with an overview of the pilot program, followed by a description of our process of selecting and evaluating sites. Then we're going to move into some of the findings identified in this ongoing effort before concluding with some insight into how we envision applying our learnings in developing broader resiliency and energy storage programs moving forward. Next slide, please. Our overarching goals with the Community Resiliency Pilot are to help communities in identifying the costs and benefits and the technical requirements of integrating energy storage resources at critical facilities to provide backup power to support continuing operations during a long-term power outage, while also illuminating avenues for Pacific Power to promote and leverage the unique grid services benefits of small-scale energy storage. The pilot also presented Pacific Power an opportunity to better understand its role in an emerging industry, as well as to strengthen ties with its communities through engagement with community leaders, energy champions, and emergency managers. Looking forward, Pacific Power's objective is to use the information gained throughout this pilot to inform its future development of community resiliency and behind-the-meter energy storage programs. Next slide, please. Slide is an overview of our process. It shows the process that we took in implementing the pilot, from identifying scoring criteria for use in site selection through to the analysis, production, and delivery of site-specific reports to participating critical facility representatives. It's worth noting here that we started developing these processes in a pre-pandemic world, and oftentimes our points of contact were involved in shaping community coronavirus response. So it was understandable that as state, community, and company coronavirus policies started to take shape, we had difficulty in both our recruitment efforts and in maintaining engagement from site representatives that had already begun the process. So now I will pass it over to Kate to talk about the next slide.
Great, thanks, Nate. So the pilot team approached site selection criteria through overlaying 2 layers, technical and economic considerations and environmental and social considerations. A key requirement for any facility to participate in the program was to have a commitment to the community during a disaster event, and that was projected and filtered through the actual scoring. So the pilot team worked with Pacific Power's regional business managers to establish contact with participants and create those relationships with energy champions in the communities. We engaged multiple sites throughout this pilot. Conversations were initiated and started with a number of potential sites. And then this actually narrowed down to 8 potential sites. The map that you see on the screen here shows a number of those conversations with sites that were started. And then finally, the group actually ended up choosing through the site selection scoring 4 initial sites for phase 1. And those include 2 fire stations, a school, and a community center. And as Nate alluded to, COVID-19 did hamper that recruitment effort. So a lot of conversations were started and stopped right when COVID hit. And we're re-engaging with a lot of those sites right now to get them back into the program for phase 2. Next slide, please. So after site selection, we began this analysis journey. So we completed both desktop reviews, site visits, and in light of COVID, we had to shift gears, so we did virtual audits as well. So first, we developed baseline load profiles. So utilizing existing utility meter data and preliminary information gathered from the sites, we developed these baseline load profiles. Second, we dug into the critical load analysis. So the audit team reviewed building drawings and equipment inventories collected on site for each facility. And then they used, through kind of confirmation with site representatives, they identified building loads and electrical circuits that would need to remain powered during an outage. And then third, we moved into evaluation of resiliency scenarios. So we identified 3 overarching scenarios to investigate. The first was kind of a conventional configuration, which includes just backup generator power. Some sites had backup generators, some did not. The second was more of an enhanced configuration, which included both the battery energy storage system and the backup power generator. And then finally, there was a comprehensive configuration, which included solar, battery energy storage, as well as backup generator to endure a long 2-week outage. The fourth step in the process was actually sizing that battery energy storage. So the pilot team evaluated the critical sites for the battery energy storage. They looked at the energy storage configurations with and without PV. They determined daily discharge and charge cycles and considered any kind of physical or technological site constraints. And then examine applicable use cases. So finally, all of this culminated into a benefit cost analysis. We assessed the potential cost for the battery energy storage system with economic analysis for each site, but also we utilized the FEMA tool to understand the resiliency benefits for these critical facilities. And we'll kind of get to that a little bit more about how the resiliency benefits built up over the course of the program. So the next 2 slides start to share the key findings of our preliminary pilot or preliminary investigation, and Nate will be sharing the first 2.
My audio at the moment, so I will look for visual cues when it's my turn to speak. Can folks hear me here? Give me a thumbs up, Kate. Thank you. So the first finding that I want to touch on for this pilot is the pilot team's recognition of the need to tie technical assistance funding for the funding. Sorry. The first finding that I want to touch on is the pilot team's recognition of the need to tie technical assistance to funding for the actual deployment of energy storage resources. This conclusion is based in part on 3 learnings. First, there's a strong appetite to take steps now to harden critical facilities against resiliency events, and battery energy storage systems can help achieve that goal by supplying backup power while reducing the risk of fuel supply disruptions that may result from a natural disaster scenario. Second, technical assistance with no assurance of funding for actual installation holds limited appeal to critical facility representatives who tended to be more interested in taking action than in academic exercises. And third, the battery energy storage industry perceives a limited market in Oregon as a result of poor customer economics. To that point, with comparatively low demand charges and time of use rates that lack a large delta between on-peak and off-peak rates, Pacific Power's rate structures don't favor the traditional avenues by which customers generally accrue benefits with energy storage resources. Additional feedback that the pilot team received was that while a grant program is well and good, a program that provides incentives for energy storage for a longer duration offers the certainty that's required to attract the vendors and installers necessary to develop a new market. Next slide, please. In addition to the straightforward resiliency benefits to the host site, the pilot team found that behind-the-meter energy storage resources offer an array of potential grid services benefits to Pacific Power and its customers, and resiliency and greenhouse gas emissions reductions benefits to society more broadly. The pilot team evaluated several types of grid services, including energy arbitrage opportunities, the ability to hold storage resources as operating reserves, the deferral of transmission and distribution system investments, and the ability to count energy storage resources towards meeting resource adequacy requirements. As reflected in the table that's included in the appendix of this presentation, the values of the grid services benefits vary by type and by year according to the needs of Pacific Power's system. But to provide a summary of those benefits, at a program capacity of 21.5 megawatts of behind-the-meter energy storage by the year 2030, Pacific Power could accrue upwards of $20 million on behalf of its customers. This value allows Pacific Power to justify committing funds to the development of programs to promote behind-the-meter energy storage that we will discuss in the section about future programs a little later. Now I'll pass it back to Kate.
All right, thanks, Nate. So as I mentioned earlier, we pivoted and we ended up in a virtual audit future, I will say. So while desktop reviews can lay the foundation of where to go with storage, a conversation or site walk is actually quite critical to understand site constraints and make more informed decisions that actually are impactful and important for the actual facility managers. So due to COVID-19, the team had to pivot. We started utilizing virtual platform tools to actually conduct our virtual audits. This not only kept people safe and personnel safe, as well as save significant time and money in conducting those audits. So what we noticed was that small to some medium commercial facilities, like those that were mostly in this pilot, do not have really complex mechanical or electrical equipment, which enables a virtual site exploration. And doesn't require extensive knowledge or training or certifications to identify specific areas or equipment that might be impacted by the new battery energy storage system. So really, this was done by utilizing initial intake forms that provide the basic information and high-level data. And then the virtual auditors created a more kind of specific walkthrough. It was usually about an hour with the site participant. And it just made the walkthrough less time intensive and more focused on certain details. Next slide. So the final preliminary finding, because as Nate alluded to, this is an ongoing effort, is one about this kind of idea of community resiliency core. And apologies for the construction in the background. The pilot explored individual critical facilities within the community. So when looking at just an individual facility, the benefit stack of storage is very limited. If we start to kind of expand this view to more of a community core, we start to create greater resiliency benefits that can be achieved more cost effectively. So this kind of looks like, so I just want to share some steps of how this will look. So it actually is about siting a virtual meter in front of the critical community facilities, allowing for greater aggregation of benefits during blue sky operations. It allows buildings to share resources more efficiently and shifts the demand load within the community core. So it optimizes for coincident peak of those buildings, as well as reduces the overall need for the storage size. So during a resiliency event, the system would have the hardwired meter, which would still need to be in place, but it could be islanded during an event and allow the community core to stay operational. While this pilot had a specific parameter, which was individual facilities, we believe that this is an eventual evolution of the program to create those greater resiliency benefits for the community. So Nate's going to kind of talk to where this is going and how this is going to be looking for us in the future.
So gazing into our crystal ball, Pacific Power perceives a real opportunity to develop program offerings around the co-benefits of behind-the-meter energy storage resources. In the shorter term, those programs may look like a combination of a grant program for critical facilities, so sort of a natural progression of this community resiliency pilot, and may also look like a customer agnostic incentive program for behind the meter energy storage, as the storage industry representatives that we spoke to suggested would benefit the development of a more robust storage industry in Oregon. One of the hurdles to unlocking the grid services benefits that we discussed earlier, beyond just customer uptake of behind the meter energy storage resources, is that grid services benefits require Pacific Power to have the ability to exercise some control over the small scale distributed resources that employ a diverse array of technology platforms, and we have to be able to do so in a way that plays nice with our broader grid management technologies and processes. So that's a meaningful hurdle, and something that Pacific Power is working to address. Looking forward to not too distant future with an ever expanding portfolio of potential distributed energy resources, including customer generation equipment, EVs, and demand response resources. It's clear that we need to be thoughtful and holistic in how we design the programs, policies, rates, and technological solutions associated with behind the meter energy storage resources. So with that, I will move on to the next slide in the Q&A section. If people have any questions, looks like we have a couple minutes left.
Thanks, Nate. Thanks, Kate. Really appreciate it. Very interesting project that you guys had underway.